this year in Algebra 2, or you're going to see it again in pre-calculus or college algebra. You're just going to, they're going to be there. So we had done the sum of two cubes a couple of times, but we didn't do the difference of two cubes. And it's not that big a difference, because what we're doing is we're talking about a sign change. I mean, that's really what it is. So when you look at n cubed minus 216, if you're thinking, okay, 216, not real sure about that one, we could always use that math button, remember? Where we have the cubed root piece, you know, because we haven't dealt a lot with those perfect cubes. So if you don't know what that is, you can punch it in, you know, and see, oh, it is a 6. So this is n cubed, and this is 6 cubed. And then you think back to what we talked about for the formulas for a cubed minus b cubed. And again, it's just logical that, you know, we've got this cubic situation. There has to be an a minus b in there somewhere, you know? It just makes sense. And then we'd have to have a squared and b squared so that when we multiplied that through, we'd manage to get a to the third and b to the third. But we don't want a middle term. So our middle term is going to need the opposite sign of what we see in the first set of parentheses, or we're going to be in trouble. So that would be plus AB. So with this one, the negative comes immediately in the first set of parentheses, and then the second set doesn't have any of those at all. And we're just going to substitute our n and our 6 in here. And then again, like I said, 98% of the time, once you have gone this far, it generally is not factorable. But you could always check and ask yourself, okay, this could be a perfect square trinomial, but because we know that generally this is not factorable, I might even not try that. I might just say, are there two numbers that multiply to 36 and add to 6? And just go through that list really quick and realize, you know, there's nothing that I'm going to be able to do there. All right, example 8. This is where we'd say, okay, is there something that I can take out of both of these? You know, it's always that greatest common factor piece. And so you sit and you try and you think, well, 27, let's see, I could try 1 and 3 and 9, and nothing's happening there. But then you realize, wait a minute, that's a perfect cube, so I might still be able to go after this. 64, well, that's 4 times 4 times 4, so that's a perfect cube. And again, we have the formula for this as a minus b times a squared plus ab plus b squared. But because this one has numbers in both our a and our b terms, that's where people tend to make mistakes. So you want to slow down a little bit, not necessarily the first set of parentheses, people generally do okay there. But right here, first step, second step, that's where people mess up. Because we need 3x, the entire term, squared. And that's going to be a 9x squared. Middle, you have to multiply those numbers together. So 3x times 4 is 12x. And then don't forget to square your 4 at the end. So sum and difference of two cubes. They really are just formulas. And like I said, if you can reason logically through them, then it's not about memorization, and it won't take you too long to get used to that pattern as you go through it. Now, this stuff was actually kind of stuck in front of 5-3, bless you. And that's because 5-3 assumed that you remembered all this stuff from the past. And actually, they might have spent a day or two on this pattern in exponential, but that would have been about it. Most people just don't remember those formulas if they haven't used them since then. So now we'll start the actual section, which is solving polynomial equations. Carl Friedrich Gauss wrote the fundamental theorem of algebra, and it said if it's got an x, it has an answer. And all of this math was generated from that, all the things that we can do. So when we can factor, we absolutely want to do that. It's a part of solving that makes things a little bit easier. Sometimes we can't, and that means we might have to grab the graphing calculator to find some of the zeros. But we want to solve polynomial equations by factor whenever we can. And we are going to have to solve some polynomial equations by graphing. Not sure we'll get there today, but we'll go as far as we can. And to do that, I am going to skip the getting ready. And that one involves figuring out how to get a visual of the perfect cubes. But what we need to do is figure out how to get all these solved now that we've already talked about that formula. So factoring ax squared plus bx plus c obviously can help us solve. You know, we've been doing this all along and trying to make that connection with, hey, these are the x-intercepts, so we can know a lot about our quadratics before we graph them. So our essential understanding is x minus a is a factor of the polynomial. And notice again that's a linear factor. Then the polynomial has a value of 0 when x equals a. Because if we put a in here, a minus a would give us 0. If a is a real number, then the graph of the polynomial at the point a0 has an x-intercept. So there's our connection with what we're going to see visually. To solve a polynomial equation by factoring, write the equation in the form your polynomial equals 0. And solve it. Well, that's what we're doing by factoring. And once we factor that, it's easy to figure it out. And again, remember it says use the zero product property to find the roots. And that's where we're saying anything times 0 is going to be 0. So this is not new. It's just that we're going to have tons of different factoring methods in the same section. It's not, oh, these are all the nice ones. You know, it's, hey, they're scattered all over the place. Now try and remember all the factoring methods that you've ever learned. And that brings us to this wonderful concept box. So concept summary, and all of these different things. So I've tried to talk repeatedly about, you know, where do you start? I mean, look at all of this stuff. There's so many different places to go. The first thing we always do is factor out a GCF. So we should put a number 1 up here. So that's first step, no matter what. Factor out a GCF. But the second step, it's a little fuzzy because what you want to do is you want to notice those perfect square patterns, but we have so many different perfect square patterns now, and now we have perfect cubes that we could notice. So step 2 would really be this, this, and this. You say, I'm not able to pull anything out of all of these. Wait a minute, this is a difference of 2 cubes pattern. Oh, wait a minute, this might be a perfect square trinomial, or these are both cubics. Well, maybe this is one of those sum of 2 cubes or difference of 2 cubes problems. So this really comes to powers. After you've pulled out that factor that you can take out of everything, do you notice that you have unique power situations? So those would all kind of be the same step. You're noticing all of those powers. And then we would probably go right here. Because the next thing to notice really easily would be, hey, this has 4 terms. What factor stuff with 4 terms? Well, we try factoring by grouping. All of this fails. Now we're up here. Just trying good old-fashioned factor. So, greatest common factor. Check for special power situations. Check to see if it's 4 terms, so you're factoring by grouping. And if all else fails, go back to good old-fashioned factor. And again, we have seen all of these patterns now. Problem is, at some point, at some point, we're going to see things that are not factorable. And when that happens, we need a backup point. And that's what we run the calculators for. So this one says solving polynomial equations, and we're definitely going to use factors for this. What are the real or imaginary solutions of each polynomial equation? And as soon as you read this, you should be saying to yourself, they're asking me for the zeros. And if I'm supposed to give them the zeros, I got to have a 0 on one side of this thing. So I'm going to have to subtract this 3x from both sides. And we always want to put it in standard form so that we can see that highest power of the variable and work our way down. But then, just like we did in the charts, you think, okay, step 1 is always GCF. So do I have something I could pull out of all 3 of these terms? What is it? Have to. I have to do that. Now they said we were going to do this by factor. So this must be factorable. Remember that x continues to come along for the ride. But I don't know that I'm going to write down all the combos this time because there's a 2 in front. And there's not a lot of numbers that multiply to give you 2. One of them has to be 2x and the other one has to be x. And I look in the back and I see there's not a ton of factors there either. I mean, if it's -3, it's either going to be 1 and -3 or -1 and +3. So just try to work my way through the numbers and outside times outside plus inside times inside. So a -5. Well, with this combination of numbers, a -6 plus 1 seems to be the way to go. So I think, all right, well, 2 times -3, that would give me the -6 for outside times outside. And if I put a +1 in here, then I'll have -6 plus 1. And I'll get my -5. And there it is. Now, I'm not done. And technically, we shouldn't drop the equal 0. When you get to college algebra or pre-calculus, if you drop that equal 0, it's called presentation error. You lose points for that. So we know we're finding zeros at this point, but this tells somebody that's grading your paper, I know I'm finding zeros. It gets across that you know exactly what you're doing. So wherever there's an X, there's an answer. What's the answer here? 0. And this one, we might write it down for a second just so we can see those 2 steps in our head. Subtract 1 and divide by 2. There's another one. And then the last one, that most people can just look up there and see, yeah, that's going to be x equals 3. And then go back to the directions for a second and see, did they just want solutions? Because if they did, we're done. But if they said, find the y-intercepts, then we have to write these as ordered pairs. What are the solutions? So we're done. We have 3 of them. And notice this was a degree 3 polynomial when we started, so we should have 3 answers when we get done, whether or not they're real or imaginary. In this case, they told us the stuff was going to be factorable, so that tells us they're going to be real. All right, let's look at B. What's wrong with it? Yep, let's move it over. What do we do that? X squared, everybody okay with that? All right. Would that be a perfect square trinomial? Is it? Two numbers that multiply to 4 and add to -2. It's not that bad. All right, well, let's do the easy one first. 3x squared equals 0. Divide both sides by 3. Take the square root. So, solving polynomial equation using factors. And it's not factorable. It happens. We did get one piece of this that was factorable, so they were trying to help us out with that piece, but this piece isn't. So now, backup plan. It's not factorable. We decide whether or not this would be a good one to go after by completing the square, or if it would be a good one to put in a quadratic formula. I think these are some pretty nice numbers for completing the square. And you're going to have to do a lot of completing the square next year at pre-calculus. So let's remember that process. With completing the square, we say, well, this 4 didn't work. So I'm going to go ahead and move that over to the other side. So I have to do is find the number that would work. What would that number be? Do you remember the formula? Okay, your heads are down, so I'm hoping you're doing this on your own. What's the little formula? Good. So negative 2 divided by 2 gives you negative 1, and when you square it, you get a 1. So what's going to go in the parentheses? X minus 1, the quantity squared. All right, so this is why we couldn't factor it. This is going to be imaginary. Because your next step is to take the square root of both sides. So we'll have plus or minus I square root of 3, or the square root of 3, I. And then we'd have to add 1 to both sides. So x equals 1 plus or minus I square root of 3. Nothing said it had to be in standard form, so there it is. Is this a cubic way up at the top? Did we just find 3 zeros? Here's one right here, and here's the other 2. 1 plus I square root of 3, and 1 minus I square root of 3. But we have them all. So, did we factor? Yes. We factored out a common monomial factor. We took that out. But in the end, we couldn't factor to get the last 2. 1a says, what are the real or imaginary solutions of each equation? And we have x squared minus 1, in parentheses, x squared plus 4 equals 0. I'm thinking, they helped us out. But one of these can still be factored. First set or second set? First set, this is a difference of 2 squares. We don't have a sum of 2 squares formula, and that's because there aren't 2 numbers that you could multiply to 4 and get 0. It isn't going to happen. So, nice and easy ones. This one. This one. Do a little work for this one. And as soon as you set it equal to 0, hopefully you looked at that and said, oh, I'm just going to solve that. Subtract 4 from both sides. And then I'll take the square root. So x equals plus or minus what? 2i. And then I double check, did I get them all? Well, x squared, if we multiplied those together, that would be x to the 4th. That's a quartic. 1, 2, 3, 4 zeros. Got them all. It's just kind of a last second check. Did I find everything I was supposed to find? B looks like a monster. What's wrong with it? Yep. So, I guess I'm going to take the right side and move it over because I've got a nice positive x to the 5th here to lead this over. So, subtract this little bugger and add this one. Now it doesn't look quite so big and scary. Well, now what? Yeah, take out an x cubed. Is that a perfect square trinomial? Got 6 in the back. You know, you learn really quickly to check front and back up. 6 in the back isn't going to happen. So now, maybe it's factorable. Maybe we'll have to use completing the square. Let's see if we can find them. 2 numbers that multiply to 6 and add to negative 5. Multiply to 6 and add to negative 5. Yeah, this is a real common one to think it's got to be the 6 and 1, but if they have to multiply to a positive 6, they're either both positive or both negative. Huh. X cubed equals 0. Well, when you take the cube root of 0, what do you get? Still just 0. Okay, well, these two, we can just look at them and say that's going to be x equals 2. That's going to be x equals 3. I'm short some zeros. Wasn't I supposed to have 5? This little bugger right here goes to the power of 3. That means this 0 counts 3 times. That's called multiplicity. So this is a 0 of multiplicity 3. It counts for 3 of our zeros, so 3, 4, 5. Here's where I'm thinking, did we talk about that last week in Algebra 2? Okay, my pre-calc class is talking about the same topics, right? So our graph is going to cross, because this is a 3, which is odd, it's going to cross at x equals 0, and it's going to cross at 2, and it's going to cross at 3. But again, we're not doing intercepts right now, we're just talking about the zeros. So those would be our zeros, but we can make sure that we have all the zeros that we're supposed to have. Wow, those are factoring, and there's just a lot intermixed in all of this. You know, there's a lot of our past methods that we have to use here. So problem 2 says, here's some more. Solve polynomial equations by factoring. And again, they're a little different, So what are the real or imaginary solutions of each polynomial equation? So what do we have to do? Solutions are zeros. Does that x to the 4th make you a little nervous? Sure. Here's why. First thing we're going to look for is the greatest common factor. Is there anything we can pull out of all of those? No. Then we think, okay, is this possibly a perfect square, something or other? Perfect square trinomial in this case. No, because it would have to be a positive 4. All right. So good old-fashioned factoring. Wait a minute, to get x to the 4th, all I have to do is x squared and x squared. That's no big deal. I'm still just going to be finding 2 numbers that multiply to negative 4 and add to negative 3. We're not done factoring. Are both of those factorable? Are both of those factorable? No. Which one is? The first one with the subtraction in it. This is going to be factorable. That's a difference of 2 squares pattern. That's x plus 2 and x minus 2, because outside times outside plus inside times inside are going to cancel out. But 2 numbers that multiply to 1 and add to 0, those don't exist. All right, so 2 nice and easy zeros here. And one that's going to require a little bit of work, not a lot. There's no middle term, so we can just solve it. We can subtract 1 from both sides, square root. So x equals plus and minus 1. Square root of negative 1, I. 4 zeros? We have them all?
Yeah.
1, 2, 3, 4. Imaginaries always come in pairs. You don't ever just get 1. Always come in pairs. Well, that wasn't so bad. B. This is an interesting problem. Because you could say, well, before when we had x cubed equals 0, we just took the cube root both sides and we got our answer. It's not going to work with this one. And that's because there are going to be some hidden zeros that we don't see if we don't try to factor this one. So let's move the 1 over. Greatest common factor? No. Power something or other? Yes. This is a difference of two cubes. So this one, we have to use this formula for a cubed minus b cubed, or we're going to miss some zeros. Because all we would find is the first zero, and we'd be missing two more. So this will be x minus 1 times x squared plus x plus 1 equals 0. First zero, nice and easy. Back one. Remember I told you before, 98% of the time those are not going to be factorable. But we try. We say, hey, two numbers that multiply to 1 and add to 1. Not going to happen. So this is where you have to decide, am I good enough at completing the square to complete the square with fractions? Or would I rather use the quadratic form? And that's always up to you. I'm always going to show you completing the square. And that's because you need to be able to do completing the square with fractions and pre-calculus. So we would say, let's take a little step aside here for a second. And let's move that one out of the way. And let's figure out what we would need to complete the square. Well, our b value is 1. So it's going to be 1 divided by 2 squared, which is 1/4. That's not such a scary fraction. So over on the right-hand side now, we have negative 1 plus 1/4, which most people can look at that right away and say, oh, that'll be negative 3/4. Not a big deal. Working with halves and fourths, most people are comfortable. But then it's like, well, what is going on over here now? Remember, the step before told us what we were going to square. And what we needed to square was 1/2. So we have x plus 1/2, the quantity squared equals negative 3/4. Now, the simplifying gets a little tougher. Square root of negative 3. How are we going to have to write that? Square root of 3i, or I square root of 3, but however you're comfortable writing it. Square root of 4. That worked out nice. 2. So now all we have to do is subtract 1/2 from both sides, and we'll have it. So negative 1/2 plus or minus I squared root of 3 over 2, or if you want to write it in standard form, you could do square root of 3 over 2i. Either way, did not require standard form for this problem. Did we find all the zeros? We did. There were supposed to be 3. There were supposed to be 3. Do you see how we would have missed zeros if we'd have just said, hey, it's x cubed equals 1. I'm going to take the cubed root both sides. X equals 1. And we would have looked up here and said, oh, but this was third power multiplicity of 3, and we would have missed them. So we have to move things over and factor them whenever we can. 0 is a special situation. But in these cases, when it's not a 0, yeah, we've got to find them. All right. Real or imaginary solutions of each polynomial equation. So, here's what I need to know. Based on what we've done so far, 4, 3, 2, 1, 0 me, how you feel about factoring to solve. Okay, those are a little lower than I would like. If you had a partner, what number do you think you would be? If you had a partner for this. Okay, people still not confident. All right, so let's do it together then. I hoped by talking to somebody you'd feel a little better. So based on what we just did with the last one, what is your instinct on A? You got to move it over. We have to, or we're going to miss some stuff. We are. Looking for power situations. Is it possible this is a difference of two squares? It is. This is a perfect square. It's x squared squared. This is a perfect square. It's 4 squared. It is a difference of two squares. So it'll be x squared plus 4 times x squared minus 4 equals 0. Are both of those factorable? No. Which one? The second one with the subtraction in it. How do you factor x squared minus 4? X plus 2, x minus 2. Good. So here's the easy ones. X equals negative 2. X equals 2. What are we going to have to do with that x squared plus 4? Yeah, we've got to solve it. So let's write it out so we can get our brain to wrap around, okay, how do you solve something that looks like that? Kind of think through it. How would you solve it? Will you get both answers if you do it that way? So this one we can just solve. We can subtract 4 from both sides because when we take the square root, we're going to get a plus or minus. So this will work. How do you write the square root of negative 4 in simplified form? Did we get them all? Got 4. 2 and negative 2, and then positive 2i and negative 2i. So that last check works for us there. All right, B. What are your thoughts? Come on, some of you are already doing it. I can see you right in there. What's your first step?
Equal to 0.
Moving stuff over and getting a 0. Looks like so. Next thought? Yep, greatest common factor. Perfect square trinomial? No. All right. So we'd rather not have to complete the square. Let's give it a try. Do we know two numbers that multiply to negative 8 and add to 2? What are they? 4 and negative 2. So this one we could get just by factoring. What are the 3 zeros?
0, 4.
That they are. Cool with that one. And I write too big. So I'm going to have to copy this. Bring it on down. Hopefully you don't write as big as me. All right, C looks a little scary. Looking at that mess, can we see factors? So we're going to have to get this in a situation where we can actually see how do we factor this. We are going to have to distribute and move stuff over. We just have to, because we can't see what's there until all that multiplication is done. Now what do we do? Move it over. Anybody concerned about the 8x dropping out? No, once you get it over there, you see, right? Greatest common factor? No. What did your mind go to right away when you saw this? Difference of two cubes, exactly. This is x cubed and this is 2 cubed. So now we just have to remember the formula. And this is a cubed minus b cubed. So we'll have a minus b times a squared plus ab plus b squared. So let's see what we get. X minus 2 times x squared plus 2x plus 4. Still equal to 0. X squared plus 2x plus 4. Perfect square trinomial? No. Two numbers that multiply to 4 and add to 2? No. So, let's write down the easy one. How do you suppose I'm going to solve that little bugger? Completing the square, exactly. And this is a nice one. I've got a b value of 2. This is going to work out really nice. Find the value for me, please. What is it? 1. What goes in the parentheses? X plus 1. So what do you do next? Square roots. How do you simplify that little bugger over there? I squared is 3 or square root of 3i in standard form. It's all left but the crying. What do you do next? -1 is not a big deal. There we go. Did we get them all? I hope so. Did we get them all? 3 of them? Because that's what we found. Yeah, there are -1 plus I squared is 3. -1 minus I squared is 3, and then we had our little 2. That's some good factor in there. All right. It's not factorable. Obviously, we're going to keep working to find them. That's what we do. So if it's not factorable, we don't give up and go home. 2 rules in math. There's no crying in math, and we never give up. That's just how it works. So, real roots. Even if we can't factor it, and we get done and it's a cubic and we can't factor it. Well, the quadratic formula in completing the square only works for quadratics. It has to be a power of 2. So it's a cubic and I can't find them. Oh well, too bad. Walk away? No. We're going to use our calculator to get to some real roots. And if we can find at least one to help us do something with it, then that's what we need to do. So the next step here does require the graphing calculator. Move everything over. Because the instructions are not going to be a giveaway. They're not going to say, hey, do this way. So we would look at this and say, okay, no greatest common factor. Rats. 4 terms though. Maybe I can group this. So let's see. I could take an x squared out of there. Take a -1 out of that. Oops. These two are not the same factor. Now, could be that if we rearrange the terms somehow, we might get this factorable by grouping. But no, not with this one. It isn't going to happen. So that tells us we have to use another method. And that's where we grab the graphing calculator and see if we can figure out what they are. So, got to get that bugger in there, and you're going to use the one that's in green up here because we want to still find the zeros, and if you want to find the zeros, you have to set it equal to 0. So x to the 3rd minus 4x squared minus x plus 5. That's good. Zoom 6, so we're all looking at that negative 10 to 10 window. All right, do we see 3 actual places where this crosses the x-axis? Okay, because if we can see them, then Blinky can find them. You know, that's Blinky's job. So we're going to do second trace just like we have so often before. But now we're looking for the zeros, and that's number 2. So we want to pick number 2. And Blinky's asking us, am I on the left side of the intersection with the x-axis? The answer is absolutely not. So I'm going to use my left arrow to get Blinky to the left of the intersection with the x-axis, which just happens to be below it this time. So over here, this is left and this is right. So enter once we get down there, right arrow once, twice maybe, enter again, and then enter through guess. And there it is. And typically, because of what people will have to do in AP Calculus, we'll tell you to write these to 3 decimal places. Your book, I think, only goes to 2 or so. So we really should get used to the rounding to 3 decimal places. Well, that's only one of them. I need the other 2. Good thing Blinky's still here. So, second trace again. And number 2. But this time, this is left and this is right because the way the curve is moving. So I'm going to have to enter above the x-axis and then below and then enter through guess. 1.1630. One more, second trace, but this one is back to the green, well, kind of, where you think of below as left and above as right. So I'll get Blinky a little bit below that and hit enter. Above it, enter, yes, 3.9310. Now, we would realize if we missed something by factoring, if we went through this process and Blinky told us that one of these was 0.250. Oh man, that's 1/4. You should have been able to factor it to get that. But these 3 nasty decimals, no, those aren't anything we would recognize. They're not. So this one had to be done by the graphing calculator. We just don't have any other methods to get it. So down here, it says, what are the real solutions of x cubed plus x squared equals x minus 1? We're going to do the same thing again. Move her all over. We don't know we have to use our graphing calculator for this, so we will try factoring by grouping. We would see the utter failure. Those were not the same. And we realize we're going to have to use the graphing calculator. We don't have any choice. X cubed plus x squared minus x plus 1. Problem. How many zeros do you see? 1. How many is it supposed to have? It's supposed to have 3. Well, let's find the one we can find with Blinky here. So second trace, number 2. Down here to the left and hit enter. And then above the x-axis, hit enter. Enter to guess. So, if we only saw one, what does that mean about the other two? They were imaginary. And because this is not a nice zero, we're not going to be able to get those yet. So, one real and two imaginary. So in B it says, which method seems to be an easier and more reliable way to find the solutions of an equation and explain? Going back, we really didn't have a choice. And we didn't have a way of factoring that, and if we don't have a way of factoring it, then we're stuck. We are going to learn some more methods along the way. I know you're very disappointed that we didn't have time to get to the word problems today, because that means you're not going to have to, oh, I'm sorry, you won't be able to do the word problems in the assignment. I think I already changed it to reflect that, because I kind of assumed we weren't going to be able to get to the word problems today. So, there you go. Tomorrow we'll finish up the word problems. We'll take the little Schoology quiz on 5.1 and 5.2. And there should be work time in class.